Who wants to go fast?
I want to go fast.
As you have observed, a high-pressure racing situation can lead to a variety of stresses on a competitive vehicle. The aim of this project was to determine the performance of the current iteration of the throttle linkage for the SAE Baja car. Dynamic and static analyses were done for the current design to determine the forces present at the joints at full actuation of the gas pedal. FEA was then used to analyze the frame joints under these forces in order to predict their robustness. Originally, the car's throttle was linked via cable directly to the gas pedal, but because more linear displacement of the throttle was desired, a linkage was designed and added to the car. The first and second designs failed at the frame joints, so the current iteration incorporates more robust supporting members, and a throttle stop was also added in order to limit the amount of force placed on the linkage. Parameters such as the dynamic force on the pedal were measured, and a dynamic analysis was then performed on the linkage to determine the forces on the joints of the ground link. The static input force on the system was also analyzed to determine the strength of the linkage when a throttle stop is not used. When the forces with their corresponding directions were determined, FEA was performed on the ground link. The joints proved to be fully capable of withstanding the loading associated with the dynamic input with a factor safety of approximately 2. The static load, however, is sufficient to cause joint failure. These results validate the current design, provided that the throttle stop is included. This will ensure that the linkage is only placed under the lower dynamic load and should perform well in the long term. If the throttle stop were removed or the pedal were to slip past it, however, the frame joints would likely fail once again, unless designed to be even more robust. Thank you.